All right, let's look at some related rates. Now, so far we've been using derivatives to find dy dx. We've been finding the derivative with respect to x. But we can find rates of change of two or more related variables that are changing with respect to time. So instead of finding it with respect to x, dy dx, we could find it with respect to time, dy dt. So let's look at this first example. The example says the variables x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. Find dy dt when x is 1, given that dx dt is equal to 2 when x is 1. So first, let's identify what we're finding. We're looking for dy dt. They've given us a couple of hints. It's given that dx dt is 2 and x is equal to 1. So let's take the derivative of this problem with respect to time. So I have y equals x squared plus 3. Now when I take the derivative of y, I get 1, but remember, I'm taking it with respect to time, so I have to write dy dt instead of dy dx. Bring down your equals. Derivative of x squared is 2x. Now, generally, we don't write dx dx, but because we're taking it with respect to time, we do have to write dx dt. And derivative of 3 is 0. Now, let's fill in the given. I'm looking for dy dt. I have that by itself. I know that x is 1, that's given, and I know that dx dt is 2. So I can solve this. Dy dt is going to be equal to 4. 2 times 1 times 2 gives us 4.